Good morning guys. Welcome to my channel Mind Your Math. Today we are going to learn the chapter Arithmetic Progressions. What does this chapter actually deal with? This chapter deals with patterns, mathematical patterns. Patterns exist in our daily life. Sometimes we notice the pattern. If it is something which is strikingly beautiful, we notice the pattern. But there are so many cases wherein we do not notice the obvious pattern that is being shown to us. For example, you are traveling by a cab from one place to another, and suppose the driver tells you he has to charge you 30 rupees for the first kilometer, and for every additional kilometer he has to charge you 10 rupees extra. Okay, so for the next kilometer you have to give 40, then you need to give 50, then you need to give 60. So the more you travel, you need to shell out more following this particular pattern. What can you notice in this pattern? You can notice that after every kilometer, as the driver told you, you are shelling out 10 rupees extra. Now look at this particular diagram. It is supposed to be a triangle made up of books. So when you are arranging like this, and suppose the successive layers, this is the bottom layer, this is the upper layer, successive layers has got lesser number of books in this pattern, 12, 11, 10, 9, 8, 7. So starting from the top, this follows. Okay, what can you see here? The number of books between the successive layers is a +1. So you start from one, add a book, you get the second layer, add a book, you get the third layer until you get to the bottom layer. In both of these patterns, you can see that the difference between the successive terms is a constant. See, +1, +1, +1, +1. Okay, this type of progressions or patterns are called as arithmetic progressions. Okay, now there are certain progressions. Actually speaking, there are a variety of progressions. After arithmetic progression, you will learn about another progression, not in grade 10 but in grade 11, wherein the difference between the successive terms, suppose the first term is a 2, the second term is a 4, third term is a 8, fourth term is a 16, and the fifth term is a 32. I am stopping the progression over here. What can you see? You can see that the difference between the successive terms is a 2, but it is multiplied. It is not added. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. This type of progression is called as a geometric progression. When you are adding the same term in order to get the next term, it is an arithmetic progression. We also study about another progression which is a harmonic progression in grade 11, which is a mix of arithmetic and geometric. But thankfully for this particular year, you need to concentrate only on arithmetic progression for the NCERT syllabus. Now, before I proceed with this particular chapter, so I want to tell you to like, and if you actually find my videos useful, subscribe to my channel. And if you have any doubt regarding the contents of what I am teaching here today, you can mail me in the mail at the mail ID given below in the description box. Now let us focus on arithmetic progressions and move on with our chapter. Guys, I have written down a few progressions over here. Let us find out the difference between the successive terms. In the first one, difference between the second term and the first term is a +7, which means 2 + 7 gives me 9. What about the third minus the second term? 18 minus 9 will give me a +9. Correct. 26 minus 18. What is the value? +8. 34 minus 26. What is the value? Right? Okay. Now, look at this. The difference between these two terms is a +3. 13 and 16. Difference is a +3. 16 and 19 is a +3. 19 and 22 is a +3. Okay. Third progression. -100 and -98. The difference is a +2. Here, am I right? Look at this one. The difference is a +4, +4, So what can you see in these progressions or the examples that I have given over here? The difference between the successive terms is a constant in the second one. In the third one also, the difference is a plus 2 between the successive terms, and so is the case of the fourth one. But what happened in the first one? Here you can see that though the difference between these two terms and these two terms is a plus 8, here you have a plus 7 and here you have a plus 9. So if somebody is asking you which of these are arithmetic progressions, what can you say? Only those progressions where the difference between the successive terms is constant is an arithmetic progression. So in all these three cases, the difference between the terms is a constant. So this is an arithmetic progression, this is an arithmetic progression, and this also is an arithmetic progression, but the first one is not. Identify which of these progressions can be classified as arithmetic progression. So you know that in order to find out if a progression is an arithmetic progression, we need to find the difference between the successive terms. Okay, so let us see here. What should be added to 3 in order to get 2? It is a minus 1, right? 2 plus minus 1 is a plus 1. Minus 1 plus 1 is a 0. 0 plus minus 1, okay. Correct. In each of these cases, the difference between the successive terms is a minus 1. So I can safely say this is an arithmetic progression. Let us look at the second one. 60 minus 54. 66 minus 60. 72 minus 66. 78 minus 72. 84 minus 78 and 90 minus 84. So in this case, the difference between the successive terms is a plus 6, constant in all the cases. So this is also an arithmetic progression. Right. Now, the third one, 3 and 3 plus root 2. I need to find the difference between the second term and the first term. It will give me a root 2. So the difference between these two terms is a root 2. Difference between 3 plus 2 root 2 and 3 plus root 2. Let us see what it is. 3 plus 2 root 2 minus 3 plus root 2. 3 and 3 gets cancelled. 2 root 2 minus root 2 is a 1 root 2. So here also it is root 2. 3 plus 3 root 2 minus 3 plus 2 root 2 is again a root 2. So you can see that the difference between the second term and the first term and the third term and the second term and the fourth term and the third term is a root 2. So I can say that that is also an arithmetic progression. Okay. Now the fourth one. The fourth one is a little tricky, but let us see how we can find out the difference between the successive terms. In the fourth one, what is the difference between the second term and the first term? Second term is a 1, first term is a root 5. I cannot simplify this further, so I am going to leave it there. Now I am going to find out the difference between the third term and the second term, which is 2 minus root 5 minus 1, which is 1 minus root 5. Correct. Now let me check the third term minus the second term. 3 minus 2 root 5 minus 2 minus root 5. 3 minus 2 is a 1. Minus 2 root 5 minus root 5 is a 1 root 5. 1 minus root 5. You can see that the common difference is constant, making this into an arithmetic progression. Whenever you are trying to find out the difference between the successive terms, please remember that it is always the second term minus the first term or the third term minus the second term. Okay, it's a higher term minus the lower term. It is never the first term minus the second term. It is always the second term minus the first term or the third term minus the second term or the fourth term minus the third term. It is never the other way around. It is not third term minus fourth term. The sign of the difference will change. Okay. Now, let us learn two new concepts regarding this particular arithmetic progressions. You have seen that this difference between the successive terms is a constant. This particular value is called as the common difference of arithmetic progression. So if somebody gives you an arithmetic progression and asks you to find the common difference, all you need to find is the difference between the successive terms. So if you are given an arithmetic progression, you already know the arithmetic progression, and somebody is asking you to find that, you know already it is an arithmetic progression, you don't have to check anything. Somebody is asking you to find the common difference, just subtract the second term minus the first term. You will get the common difference. Now, each of these numbers which is given in every single progression are called as the terms of the progression. Okay, so now if you look at the fourth progression, how many terms does this progression have? Root 5, 1, 2 minus root 5 and 3 minus root 5. There are 4 terms in this arithmetic progression, and the common difference is a 1 minus root 5. The first term of the arithmetic progression is the root 5. Okay. Now let us take another arithmetic progression, identify the common difference, the first term and the number of terms. Identify the common difference, the first term and the number of terms of the given arithmetic progressions. They are already given to be arithmetic progression, so you people do not need to check whether they are arithmetic progressions or not. We need to find the common difference and these two factors. Let us start with the common difference of the first one. I told you it is always the difference between the term minus the term before it. It is always the second term minus the first term. It is never first term minus second term. So in this case, let it be 5 by 3 minus 1 by 3, which will give you 4 by 3. What will happen if I am doing first term minus the second term? I will get 1 by 3 minus 5 by 3, which will give me minus 4 by 3, which is exactly opposite to this. Okay, so I hope you are clear how to find the common difference. Now the first term is a 1 by 3. Number of terms 1, 2, 3, 4, 5. There are 5 terms. Okay, second one. What is the first term? AB. How many terms are there? There are 3 terms. Now I need to find the common difference. So the common difference, I need to subtract second term minus the first term. You can also do third term minus the second term. It will give you the same value. So 2AB plus C minus AB. This is AB plus C. AB plus C is the common difference. Okay. Now the third one, 100, 98, 96, 94, 92. Okay. And the progression doesn't stop here. It goes on and on. Now the first term is 100. Let us find out the common difference. It is 98 minus 100, which will give me a minus 2. So the common difference of this particular progression is a minus 2. So what do you understand from this? The common difference of an arithmetic progression can be positive or negative. Right? So here it is a minus 2. Here it is a 4 by 3. Here it is AB plus C, which is variable. So depending upon the progression, the value of the common difference can be either positive, negative, or if it is dealing only with variables, can be a variable term also. Okay. Now how many terms are there in the third progression? As you can see, I cannot count the number of terms because the progression is infinite. So this is an infinite arithmetic progression. So what do you understand? An arithmetic progression can have a fixed number of terms like we saw in all the before cases, which is called as a finite arithmetic progression, or like this one, it can be infinite also. Okay. So what have we learned so far? We have learned how to identify a progression as an arithmetic progression. We learned how to find the common difference, how to identify the first term and the number of terms. In that process, we learned an arithmetic progression can have a fixed number of terms called as finite, or many terms which is uncountable, which is an infinite arithmetic progression. Okay. We also learned common difference can be positive, negative, or it can consist of variables. Right? Now let us move on to the next part. Write down the APs whose so and so values are given to us. Now, let me make you familiar with the few short terms that we are using in this particular chapter. AP obviously means arithmetic progression. A. A is the variable that is used to represent the first term. So, in any arithmetic progression, the first term is represented by A. Okay? And the common difference is represented by small letter D. Please remember all these things because this is what normally appears in the questions. So the first term is A and the common difference is D, and it is not just about the question. Even for formula we use A and D, and the number of terms is normally denoted by small letter n. Okay, so these are three variables that you should be familiar with when you are studying this chapter. The first term A, the common difference D, and the number of terms n are the main ones. Okay, now let us do all these sums. Let's do the first one. The first term is given as 10. The common difference is a minus 3, which means when I am adding common difference to the first term, I get the second term. So 10 plus minus 3 will give me 7. Correct? Third term, 7 plus minus 3 is a 4. 4 plus minus 3 is a 1. How many terms do I need to write? Write down the APs up to 4 terms. So, because the first term was already given to us, I will write one more term. So, 1 plus minus 3 will give me minus 2. Okay. So, 10, 7, 4, 1, minus 2 is the arithmetic progression under the conditions that is given in the first question. Now, let us do the second one. The first term is D. What is the second term? The second term is, we get the second term by adding the common difference to the first term. So, D plus A. This is the second term. What is the third term? To this, we again add the common difference. So, I will get D plus 2A. The next term will be D plus 3A and D plus 4A. 1, 2, 3, 4, 5. Since the first term was already given to us, I will write one more term which is D plus 5A. Okay. So, this is arithmetic progression whose first term is D and the common difference is A. Now, let us do the third one. The first term is 100. So, I am going to write it here. The first term is 100. The common difference is 0. So, what is the second term? 100 plus 0, which is again 100. The third term is 100. Fourth term is 100. There is no change in the term because the common difference is 0. So, this is the required arithmetic progression. Now, this one. 65 and minus 5. So, the first term up to 4 terms. First term is 65. The second term is 65 plus minus 5 giving me 60. Then I have a 55. Then I have a 50, 45, 40 and so on. Depending upon the number of terms, write down the arithmetic progression. So, I hope you are clear with this kind of sums. These are very basic. Will hardly come for 1 mark. Because we are starting with the concept, I have done multiple sums in this. So, the first term, adding to the first term with the common difference will give you the second term. Okay. So, now let us move on to how to find out the nth term of an arithmetic progression.